this. All right, for this proof, I just want to review a concept from a little earlier in the year, and this leads into our big fact, a circle fact for today. We're done with angles. Okay, we're done with angles. That whole second section was on angles. Now we're going to do how do you find the length of a chord today? All right, instead of how to find the angles in Scribe Central, how do you find the lengths of the chords? So I want to go through this proof, and this at the end we'll talk about our new fact here. Okay? Who's digging deep here? Who is digging deep? 7:49 in the morning, digging deep. What unit did we see this type of proof in? This times this equals this segment times this segment. You have seen this already this year. You have. We did a ton of proofs on them too. What unit was it from? Come on, let's dig deep. What unit? Anybody remember anything? Come on, show off. Show off. This segment times this segment equals this segment times this segment. Anybody remember the unit? We did a ton of them. Go ahead, Abbott.
7.
You know the name of the unit?
No.
You're just going to say 7?
7, yeah.
I don't even know what unit 7 was, to be honest with you. I have no
Similar
idea. Let's see,
triangle
5.
unit?
Oh, yeah, well, go ahead.
Similar triangle.
It's from similar triangles. Anybody remember what we used to write in the reasons column for that statement? Product of the... It was similar triangles. Product of the means equals product of the extremes. There we go. But before I could write that, Abbott, one more time, what am I going to have to do with these two triangles? Prove them similar. All right, so that's our first step. Get these triangles similar. And now, come on, let's keep the ball rolling. Main method in a proof to prove two triangles similar. Angle, angle. All right, let's do it. Can you guys find me two pairs of congruent angles so I can prove them similar? So this is going to turn into a similar triangle proof. And then I'll get you to our proof statement. All right, so can you find a pair of angles that are congruent either from past units or, hey, this circle unit, can you find me a pair of angles? Who's taking up first? 5?
Angle BCB is equal to angle DAB.
Okay, can I just put C and A?
Yeah.
Is that all right? Yep. Oh, you took the hard one. Look at you.
And
Whoa, 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 whoa. Yes, C is congruent to A. Look at using a circle fact. Good for you. What do you got for me? Why is that true?
Because the inscribed angles drawn to the same arc are congruent.
Woo! Nice job. Anybody got another pair for me? 2, another pair?
Angle CEB and angle DEA.
Yep, because they're what?
Vertical angles.
Yep. Also, if anybody wanted to just put B and D in the same step too, same reason, right? B and D are both inscribed angles drawn in the same arc. But I like the verts in there too. That's nice to have the verts in there. So angle CEB is congruent to angle AED. Vertical angles, if anybody's still spelling vertical, VIR, embarrassing. It's fourth quarter. All right, good work, good work. Now I have angle, angle. Now tell me the triangles are similar. Triangle CEB. Everyone remembers the similar sign, the tilde. Similar to CEB, AED. All right, I'm not going to go to means and extremes, though. There was a step in between. Anybody remember that step in between before I get to means and extremes? It's not 5. Step 5 is not means equals extremes. Here's a hint. I need means and extremes. What do we mean? Literally. Means and extremes. Where are means and extremes always located? What did you have to have in front of you to have means and extremes? What? Ratio, proportion. Good job, Nate Dogg. Yep, got to have a proportion. With the means and extremes built into it. Go back to the proof statement. You should know where to write all these segments now. So AE, where should I put BE then if I'm multiplying with it? Where does BE have to be? If I'm going to do AE times BE, where does BE have to be in my proportion? 3? Spence, dig deep. If I'm going to go AE times BE, how do you usually solve proportions? So where's my BE have to be?
Bottom right.
Darn right. Ha! Bottom right, darn right. Yeah, I'm good. CE, DE. All right, who's got the, come on, what's the reason here? Not means and extremes. Why are the sides in proportion? Why are corresponding sides of similar triangles in proportion? It was an abbreviation.
CCSTP.
Spence? C, not CPCTC, that's for congruent triangles.
CCSTP.
Too many C's. Corresponding sides.
Similar triangle.
You gonna tell me the letters? Come on. You had it, but yet it was CC, huh? C, S,
CP.
corresponding sides in similar.
Oh, CSSTP.
There you go. CSSTP. Good. I'm really milking this. And then, all right, now you can tell me AE times BE equals CE times DE. Product of the means equals product of the extremes. All right, good work. A lot more than I thought you would have had in you there. Product of the means equals product of the extremes. All right, did I want to review a similar triangles proof with you? Sure, but the main reason we're doing this is to come up with the next circle fact. What are A, B, and CD in my diagram? Here you go. A, B, and CD. What are they in the circle? Definitely know this one. 12, A, B, and CD, they are? Segment A, B, and segment CD. What do I call those in the circle?
They're chords.
Yeah, they're chords, right? So here's our, I had two chords, ready? So if two chords intersect, now I'm just going to add a little math trivia. What do I call the answer to a multiplication problem? Iris? Product. So if two chords intersect, ready? The product of their parts are equal. And that's what we just showed right here. Two chords intersecting, the product of their parts are going to be equal. And it's easy to say it. Let's actually put it to use now. All right, let's put it to use. Very simple here. All right, I'm going to take it very basic with you right now. So 2, Nate, here you go. What are these segments right up here called? Chords. Everyone see the chords and they're intersecting. So the product, when I multiply their parts, they're equal to each other. So everyone focus on just one chord. I don't care which chord it is, and give me the two parts that make up one of the chords. 10, give me two of the parts that make up one chord. Okay, so I'm going to write 2 times x. Their product is equal to the product of the other two parts. Give me the other two parts that make up the other chord. 9, what are the other two parts? 8 times 2.5. There you go. That's the fact we just went over. There it is. Everyone see it? Go ahead, calc it up. What do I got there? 2x equals 16, 8, 24? No, is that 24? No, it's not. Not even close. 8 times 3 is 24. 20? So x equals 10. All right. So does everyone see it? I just wanted to go over a basic one before. I don't even have that one on here, huh? All right, let me put that one on real quick. All right, go ahead. You can go ahead and draw your diagram for number 2. Draw your diagram. You have chords A, B, and RS that intersect. Where do they intersect at? Point E. And it tells me what AE is 3, EB is 16. And now I have the other 2 parts are in a ratio, and we guys know from last section, you put x's with them, right? 3x and 4x. All right. Everyone all right with the setup? All right. So I have 2 chords that intersect. So the product of their parts are equal. Give me 2 parts right now of 1 chord. Let's go 10. 2 parts of 1 chord. 3x, 4x. And what about the other 2 parts from the other chord? 9. 3 and 16. All right, let's see who was an algebra champ last year. I know that's 48. 1, Anna, how'd algebra go last year?
Great.
Great, good. How about 3x times 4x?
12x.
It went great?
Yeah. I had a calculator.
I think you're missing something.
12x squared?
There you go. Yep. Add your exponents, 1 and 1. All right, I got to get x by itself. Who's up next? 3. Spence, how'd algebra go last year?
All right.
All right, good. What do you think you do next?
Do you take the square root?
Not yet, and not until the squared is by itself. And it's not by itself. What's attached to it?
12.
Yeah, so I got to get that out of there. So what?
Divide by
Yeah,
2.
and then, yes, you can take the square root, but it's got to be by itself. So x squared equals 4, x equals 2, but we want to, bless you, make sure we saw, and what's the problem say? Find RE. We're not done yet. RE, and then it asks for ES. All right, plug your 2 back in. Let me know. RE, what's your value of RE? 10. 6. How about ES? 8. Yep. And everyone see it works out, right? 16 times 3 is 48. 6 times 8, 48. It works out. All right. We're good? Okay, let's go. I think I got that one next, right? You got this one here next. All right, go ahead. Fill out everything you have here. Find the length of chord CD. If it is 3 centimeters from the center. Okay, everyone, all right, where we're going to put our 3? The chord is 3 centimeters from the center. And the radius is 5. Can anybody put any other lengths on here? I put my 3 and the 5 there. Can anybody put anything else they know the length of, Spence?
The 2 and the little thing.
Yeah, good job. Because look, this is also radius going to A, and I already know that part's 3 and any radius is 5, so that's got to be a 2 spot right there. Yep. And we're not done with circle facts, though. You might be done with quiz 2, but we're not done with circle facts. Anything happening to CD there? Oh, you're on fire, Spence. Hey, radius, diameter, perpendicular to a chord, bisects the chord, right? So I know both pieces are equal. And we're supposed to find the length of that chord, CD. Okay, first thing I want you to focus on. Do you see in that diagram 2 chords that intersect before I go up and highlight them? Do you see 2 chords intersecting? If you do, I'm going to ask you which ones they are. All right, name the 2 chords that intersect each other in that diagram. Name 2 chords that intersect each other so I can highlight them. 6. Good. All right, so here you go, everyone. I'm going to highlight AB. Intersects chord CD. So now I'm going to use the fact we've been doing all today. The product of their segments are equal. So let me start with chord AB. Everyone focus on chord AB. It is broken up into 2 segments. What are their lengths? Chord AB, or a diameter, chord AB is broken up into 2 segments. What are their lengths? 7? So I got chord AB, right? Mm-hmm. It's broken up. CD is breaking it up into 2 segments. How long are each segment? What's the for 2 times 8? Everyone are right there. 2 times 8 equals. Now go to chord CD. There's no labels, but at least we know it's being bisected. So I can say X times. I know they're both the same length, so I can put X and X. And then now you're on your way. Be careful, though. At the end, X squared equals 16. X equals 4, but you got to answer the question, though. What's the length of CD here? 8, length of CD. 8, got to double it. Yep. So does everyone see the 2 chords? Remember, diameter is a chord. If 2 chords intersect, their pieces are equal. All right, ready for a challenge here? I'm sure you are. All right, find X. All right, first thing, find 2 chords that intersect each other. Find 2 chords that intersect. Everyone see them? I'll highlight them right here. I have this chord here. And then I'm going to have this chord right here, the diameter. All right, start with my blue chord up there, please. Start with my blue chord. What are the 2 pieces, 2 segments of my blue chord? 10? Okay, so at least I know I'm going to go 8 times 10 equals. Now let's go to the other chord, the green one, the diameter. Everyone agrees 1 piece is going to be X? All right, now we have to work. How do you find that other piece, which I'll highlight in yellow now? How long is this piece right there? Because it'll be X times that piece. And I don't know if I'm going to find just the number length here. Is this a tough one? Not expecting an answer here. I'm just looking for a little help here. 1, here you go, Anna. What's this 12 here, Anna? That's a radius. So that would mean this diameter is how long? Well, more than 12, but I can tell you exactly how long it is.
24.
Everyone all right with me so far? It's 24. Okay, Anna, keep going. This part's X. The whole thing's 24. How can I label that yellow part then?
24 minus X.
Got it. 24 minus X. Is everyone all right how I got there? The radius is 12, so that means the full diameter's got to be, this diameter's got to be 24. Well, that piece was X. The rest of it, 24 minus X. Oh, we're not going to be happy here. We're okay there? 24 minus x. All right, here we go. 80 equals 24x minus x squared. Ooh, you know what's coming, don't you? Anybody see what's coming up? You have an x squared there, not square root. It's factor time, huh? All right, we can't factor unless one side equals 0. I get it. Moving the 80 over would be real easy. But I still don't like a negative x squared. You know how I roll this year. I do not like a negative x squared. So yeah, it would be convenient to move over the 80, but I'm actually going to move over both these from the right to the left. All right, so let's move over the x squared by adding it. Move over 24x by subtracting it. And we keep the positive 80 right where it is. And now I'm going to let you play around on your calculator. Two numbers that multiply to, what are you looking for on your calc? Two numbers that multiply to? Which one? 24, negative 24 or 80? 80, yep. Play around. Numbers that multiply to 80 but give you negative 24 when you add them. Don't quit. Don't quit. Find them. Find those two numbers. 9.
I know it's 4 times 20, but
Yep. You got, yeah, it is. But they got, okay, now think about it. They got to add to negative 24. What's the only signs I can put in front? So they add to negative 24. If I put positives in front, it gives me positive 24. But I'm looking for negative 24. So
it'd be negative.
negative, negative, yep. All right, everyone now set them equal to 0. We get x equal to 20 and x equal to 4. I got a problem with one of those answers. Look at your diagram. Anna, going back to you. How long was the radius again?
12.
12, right? So how can x be 20 then? Bigger than the radius? That piece is not even, that piece is part of our radius, so how can it be bigger than it? Everyone agree? So I'm getting rid of 20, and it's just going to be 4. Whew, solid problem. We okay? And I'm just going on. I didn't know where, I'll be honest with you guys, I didn't know where to put this fact. I didn't know where to put this fact. It didn't belong in the second part, but since it dealt with chords, I'm going to put it in this part. Okay? And then you guys can get going on the assignment. Here's the circle fact. If you have two chords that are parallel to each other, all right, if two chords are parallel, their arcs are congruent. Okay? If two chords are parallel to each other in the same circle, their arcs in between are congruent to each other. I'll do number 1 with you, and then I'll let you do 2 and 3 on your own, or if you want to speak up in your group, that's fine. All right, so number 1 here, AB parallel to CD. Automatically, based on this new circle fact, the arcs are congruent now, right? Arcs are congruent. We already put in that arc AB was 80. What about arc CA then? What about arc CA? 6. What's COD in this diagram? Diameter. So it forms what type of arc on the bottom and on the top? Semicircle. How many degrees in a semicircle, Nate? 180. There you go. So I have 180 minus the 80 I already know, and then the other two arcs are congruent, so I can divide that by 2. So how much for each arc up here then? or arc 6, Nate, again. 50, yep. All right, so if the chords are parallel, the arcs in between are congruent. So go ahead and do the next two, and then we'll call it a day, and you can get going on the assignment. Remember at number 3, if the chords are congruent, so are the arcs. All right, if chords are congruent, so are the arcs. If they're parallel, the arcs in between are equal. That's 140 and 125 looking. And once you're good, go ahead. Keep going. I don't need to stop you. Get a lot of this done here using the new fact.